Hi everyone, I'm Chen Hao, the instructor for the 128 Honors section. Today we're going to have a short lecture about Rust basics. This is part 1. We're going to learn a little bit about writing Rust code and how to get started. So what we will cover today, we're going to cover some programming basics. So like we're going to learn how to declare the variables. We're going to learn about a little bit about mutability, which is a unique feature in Rust, and we'll go through some of the data types and also the control flow, such as your if statements and loops. So a lot of this lecture today is based on chapter 3 of the Rust book, titled Common Programming Concepts. We have linked the book in the resources channel of the Discord, so feel free to check that out if you have difficulty following the lecture today. So first I'm going to talk about declaring variables in Rust. So variables in Rust are in a way similar to other programming languages, pretty universal. So the syntax looks like this. So we start with let, for example here we have let x equals to 5, and in this case it defaults to a 32-bit integer. In Rust this is called an i32. A second way that we can declare variables is like the line below, where we write let x and we label it with a colon and then the type u32 equals to 10. So in this case what is happening here is that we have a variable named x. It is of type u32, which is an unsigned 32-bit integer, and then the value is 10. So these are both valid ways to declare variables in Rust, just that in most cases it's okay to declare variables without specifying the type, and Rust would use the default for the type. For example, for integers it will be i32, and most of the time the compilers will be able to derive the type from the value that you put in. So one interesting concept in Rust is the idea of mutability, where a variable could be mutable or immutable. So for example here we see that we have the statement let x equals to 5, and when we do the print line here, we expect to see that x is 5. So far so good. Now when we try to do x equals to 6, when we try to assign a new value to x and we print line, what happens when we try to compile this code is that the compiler will fail, and it will actually complain that with this error message that you cannot assign twice to an immutable variable. So this is because in Rust, variables are immutable by default. This means that when I declare a variable x like this equals to 5, the value x takes the variable x takes a value of 5, and that is permanent. We cannot reassign another value to this same variable. So this is one of the Rust safety features. It minimizes like accidental changes of variables values and reduces the some bugs. So moving on, what if we actually want to modify the variable value? So there's this keyword called mute, which is mut, and mute, well, is short for mutable or mutate. So when we declare the variable like this, let mute x equals to 5, we are telling the compiler that we are creating a variable x and it is meant to be mutable. So in this case, now when we run x equals to 6 here and we do print line, we will be able to successfully print x is 6. So this is a really important core concept in Rust about mutability of variables, and we will explore further on this topic of mutability and ownership and borrowing in subsequent lectures. Now we're going to talk a bit about the variable types that are available in Rust. For this lecture, we're going to focus only on primary scalar types. So scalar types are variables that basically take like one value instead of like a collection of values. So in Rust there's 4 primary types, which is the integers, floating points, booleans, and characters. So for integers, like we mentioned before earlier, we saw an example of an i32 and a u32. So as Min has introduced in the previous lecture, Rust is primarily a systems programming language. So in systems context, when we're programming for systems use cases, we want to be able to be clear about the length and the size of our data structures. So for example, here in Rust is quite clear. We have i8, i16 all the way to i28, and this will be 8-bit signed integers all the way to 128-bit signed integers. And on the other hand, if you have U8 to U128, the U stands for unsigned, and that means that the integers can only be positive. It cannot have a negative sign. A last number that we would like to cover is this one called I size and U size. So the length is labeled as arch, and arch is short for architecture. So actually the length of this the size of an I size or U size will be dependent on the particular architecture that your code is running on. So for example, on a 64-bit computer, U size will be 64-bit, and on a 32-bit computer, U size will be 32-bit. Another data type in Rust is floating point numbers. Again, this is how we declare it. So for example, here we have let x equals to 2.0, and this will default to F64. So the two types of floating point numbers in Rust are F32 and F64. They are short for the single precision floating point numbers and double precision floating point numbers, which have a representation of 64 bits. So in Rust we default to F64, which is the double precision, and if we want to use F32, we can declare a variable with the explicit type of F32. Next, we have the boolean. So the keyword is bool and it's true or false. So this is pretty straightforward. It's basically the same as every other language. So the last core data type that I want to talk about in Rust is the character type. So again, I've shown a few examples of the declaration here. So we have the declaration without the explicit type, the declaration with the explicit type, and this one without. So an interesting thing that I would like to bring your attention to is that these characters, for example, this sort of Z-like symbol and this crab, these are not standard ASCII characters that we're used to. So actually in Rust, the character type is 4 bytes in size, whereas like usually in a programming language like C or C++, the character type will be 1 byte. So this is because Rust uses a Unicode representation, so it can represent a lot more characters and code points than traditional ASCII that's used in C and C++. This means that we can use we can have characters representing emojis and special symbols, as including symbols from other languages and other scripts. Now we'll move on to the conditionals and as well as the looping constructs that are available in Rust. So Rust uses if, else if, and else. So this is pretty similar to other programming languages. In this example here, we define x as 50, and we have a few conditions that we check for in the if statement. So an important thing to note in Rust is that when we have conditions like this, we don't actually have to add a bracket around it. Sometimes, in fact, adding a bracket might sometimes be deemed as invalid by the compiler. So for example, these are just a few cases of the conditions that we are showing here. So the last thing that we're going to go through today is the loop constructs that are available in Rust. So Rust has 3 kinds of loops. We have loop, for, and while. So the loop itself is just, as the name implies, just a loop. It does not check any condition. It just keeps running until told to stop. So what do I mean when I say told to stop? For example, when we use the break keyword to break out of the loop, or when we have a return statement that returns out of the function. So this is like some of the conditions in which the loop will stop. But the important thing is that the loop itself does not check any condition. It just keeps repeating the code in the body of the loop. The second kind is while, the while loop. So this one checks a condition, and while the condition is true, it will keep looping. And the last one is the for loop. This one loops through a collection, such as an array, or it loops a specified number of times. So moving forward, we're going to have examples for all 3. So the first keyword is loop. So this is an example of the loop construct. So here the loop will, basically this is the body of the loop, and with the loop keyword we will just keep running this loop. So in this case, actually we have an infinite loop because we write here that if x equals to 50 we will break, but actually x will always be 0. So in this case, this will print x is 0 forever, and this is an example of a loop that will never terminate. Next, we have an example of the while loop. So For example, here in the while loop, the condition that the while statement checks before it enters the body of the loop is that x does not equal to 50, and in the body of the loop we update it by increasing x by 1 each time. So notice here that I declared the variable x with mute. If you recall, like we said earlier, this is to make the variable x mutable so that we can modify its value, and this is important because inside the while loop we are actually modifying the value of x by incrementing it by 1 each time. If we did not include the mute keyword here, then again the compiler, while compiling this code, will fail and will remind you that you cannot assign twice to an immutable variable. So lastly, we have the for loop. So this is one of the ways in which to use a for loop, which is for example here we have an array, and we can just use the for loop to loop through the elements of the array. In this case we have integers. So for example, in the body of the loop we print I love the number, so this will print I love the number 1 followed by I love the number 2 and so on for every number in the collection. Another way to use the for loop is to just loop through a range of numbers. So as you can see here, we do for number in 0 ... n. So this is the range notation in Rust, and it means where we go through the range of numbers from 0 to n minus 1. So for example, if n is 10 in this case, this will go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and not inclusive of 10. So similarly to the previous loop, this will print I love the number 0 followed by I love the number 1 and so on. So that was all the topics. Just a quick recap. We went through how to declare variables. We can choose whether to explicitly state the type in the declaration of our variables. We also talk about mutability. So when we create variables in Rust, they are immutable by default. And if we ever want to modify the value of the variable, we have to use the mute keyword when we're declaring the variable. For the data types, we went through integers, floats, character, and booleans. And for conditionals, we have if, else, if, and else. And for loops, we have loop, while, and for. So just some quick announcements. The homework 1 is released today on PrairieLearn and is due 1 week from now, so next Friday on the 13th of September at midnight. So we have office hours basically almost every day of the week, and so if you have any trouble like getting your Rust installation up or doing the first homework, please feel free to come to any of the office hours and we'll help you. That's all I have. Thank you.